call them as what? Wind. Wind always moves from high pressure to low pressure, right? Somewhere you can write the definition of the wind, my friend. What is a wind? Definition you can write it. Horizontal movement of air mass right, is called as wind. Okay. And somewhere I know wind always moves from high pressure to low pressure, right? Very important statement. Wind always moves from high pressure to low pressure, right? Wind always moves from high pressure to low pressure, right? Both the statement are very important. Somewhere I said wind or air mass of an air moving from one place to another in an horizontal fashion, you call them as wind. It always moves from a surplus region to a deficit, right? Surplus region you call them as high pressure, and deficit you call them as what? Low pressure. Has to have mass. Okay, right. Now, before talking about wind, my friend, somewhere we should establish the relation between the pressure and global circulation. Somewhere I would like to bring the difference or the relation between what? Pressure and wind, my friend. Okay. So this topic, let me call it as what? Pressure and global circulation. Right. Pressure and global circulation. So somewhere I am just bringing the relation between this pressure and global circulation, my friend. Okay. Now, somewhere I told you that wind always moves from high pressure to low pressure. Only thing is that now I should understand that why there is a pressure. Okay. How exactly a pressure system is created, my friend. In that regard, I'll just understand in this fashion, my friend. See, for example, some section I'm just taking it, my friend. Okay. Assume that this is tropopause. Okay. And say, for example, this is the surface of the earth. Okay. So one is tropopause, and of course I know that level of tropopause is not uniform, but still, in spite of the fact, I'm just taking it, my friend. Okay. So assume that I'm just trying to establish a relation between pressure and wind. Okay. Assume that this is surface. Okay. Now, my dear friends, say for example, wherever you have, say for example, I'm just taking two places, my friend. One place where the temperature is very high. Assume that I'm just talking about a very high temperature, my friend. You have a very high temperature. Okay. Another place you have a cold temperature, my friend. Okay. Now, only thing is that you have to tell me what will happen to the air mass when the temperature is very high. Okay, I'll just tell it. Means I'll just tell you, right? Whenever the temperature is very high, what happens? This air mass will get heated up. Okay. When the air mass gets heated up, this air mass expands. Okay. This air mass expands. And this expanding air mass, okay, and the air mass when it expands, okay, this air mass will start rising high in the atmosphere, my friend. Okay. So whenever the air mass expands, okay, this air mass will start rising high in the atmosphere because this air mass becomes less in density, correct? So what happens, my friend? This rising air mass creates a void at the surface. This void we call them as a low pressure. And again, the rising air mass, right, gets accumulated at the tropopause level. Okay. So when it is getting accumulated at the tropopause level, it creates a surplus region at tropopause level. That is what I call them as what? High pressure. Okay. So my dear friend, assume that this is tropopause. Okay. So when air mass is heated up, when the air mass is heated, right, the air mass rises. Rising air mass creates a void at the surface, right? This void, you call them as a low pressure. And this air mass gets accumulated at the tropopause level, right? Right, it creates a surplus, you call them as what? High pressure. Okay. So what is creating a low pressure? Temperature, no denial about it, but temperature results in a convection. Here the convection is what? Rising convection, my friend. So rising convection is the one. Rising convection is the one which is actually increasing the, rising convection is the one which is actually, right, making or creating a low pressure at the surface, my friend. Okay. So very important understanding. Okay. On the other hand, if I have a place where I have a very low temperature, my friend, what will happen? The air mass will get cooled, right? When the air mass is getting cooled, my friend, right, air mass will get contracted. It will become more in density. Am I right? So this air mass will start descending. Okay, this air mass will start descending. Okay. So this descending air mass, my friend, right, creates, right, a low pressure or a void at the tropopause level, and the descending air mass, right, gets accumulated at the surface level, my friend, right? It gets accumulated at the surface level. Okay. So this air mass which is getting accumulated at the surface level, my friend, it creates a high pressure system here, right? So somewhere I understand subsiding convection is the one which is creating what? High pressure. Okay, right. So rising convection creates a low pressure at the surface, and subsiding convection creates a high pressure at the surface. Very important, my friend. Okay. Now, normally we say high temperature results in low pressure, accepted. But is it directly? If you ask me, no. Right? It is created indirectly, my friend. Temperature results in the process called as convection, and convection is the one which is resulting in the process of creating what? Pressure systems, my friend. Very important when it comes to understanding. Okay. Right, my friend. So somewhere, let me bring that, say for example, relation. Okay. Temperature causes convection. Convection is the one which causes the pressure system. Once the pressure system is created, my friend, right, then you have a compensatory mechanism, right? The horizontal movement of an air mass which moves between high pressure to low pressure. Okay. This you call them as what? Wind. You call them as wind. Wind always moves from high pressure to low pressure. Wind always moves from high pressure to low pressure. The wind which is moving at the surface level, you call them as what? Surface wind. Or very technically, this wind, you call them as what? Advection. Technical reference of wind, you call them as what? Advection. Wind moving at tropopause level, you call them as what? Upper air wind, or you call them as what? Upper air advection. You call them as what? Upper air advection. Okay. Now if you ask me, okay, bring me or give me the relation between all this process, I'll tell you, my friend. Right? What is the relation? I'll tell you. Right? My dear friends, temperature is the one which results in convection. Right? Now if you ask me what is convection, vertical movement of an air mass, you call them as what? Convection. Already I have given you, right? Horizontal movement of an air mass, you call them as what? Convection. Convection is the one which resulting in what? Pressure system, my friend. Results in what? Pressure system. Right? Or simply you call them as what? Pressure. Right. Once the pressure system is created, then you have the horizontal movement of air mass, you call them as what? Advection. Okay. Advection is the technical term, but as a layman's understanding, this advection we call them as what? Wind, my friend. Okay. So wind is the resultant factor. So what is the relation between pressure and wind? We have seen. correct? So temperature causes convection, convection causes pressure. That's the reason sometimes we directly say temperature is the one which is causing pressure. Once the pressure is created, you have a compensatory mechanism. This compensatory mechanism, you call them as what? Wind, my friend. Okay. So what is the relation between pressure and wind? We have taken it. Okay. The circulation, you call them as what? A global circulation, my friend. Okay. So pressure and circulation. Right. Instead of global circulation, you can simply call it as what? Circulation. That's more than enough. Okay. Why to call it as global? Okay. Simply you call it as what? Right. Circulation. Fine enough. Okay. You call them as what? Pressure and circulation. That should be more than enough. And my dear friend, somewhere make it very simple. You ask me what is convection here. Whatever is the meaning in physics, I'm not bothered about it. Here, convection means vertical movement of air mass. Vertical movement of air mass, you call them as what? Convection. Then what is advection? Advection is a technical term. Advection is nothing but what? Wind. Correct. It is nothing but what? Horizontal movement of an air mass. So this horizontal movement of air mass, you call them as what? Advection. Okay. So it is not to see too technical. We will put it in layman's understanding or layman's term. Okay. So what is convection and advection? Right, my friends? Okay. Right. So what is convection? What is advection? As a layman, we tried understanding. I hope you understood. Okay. I repeat again, my friend, this concept, what you are seeing is very, 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 very important. Okay. Right. So predominantly, if you ask me, where we have wind, because we are going to talk about wind now, right? So predominantly, we have wind at two places, my friend. One, wind at the surface level, and two, wind at the upper air level, my friend. Right, wind at surface level and wind at upper air level. Okay, now with the small idea, what we'll do, right? We will talk about wind, my friend. We'll talk about wind. Okay. Now we know we have two types of wind, my friend. Or wind flowing at two places we have. What are the places we have this wind which is flowing, if you ask me? Predominantly, we have wind which is flowing at what? Surface level and upper air level, my friend. Upper surface or upper air. Okay. You call them as what? Surface wind. And you call them as what? Upper air wind, my friend. Call them as what? Upper air wind. You call them as surface wind and you call them as what? Upper air wind. Okay. Okay. Now, we're talking about surface wind. Okay. Now, what is the surface wind? All this wind which is flowing at the surface level, you call them as what? Surface wind. So, this wind, depending upon the size, my friend, the surface wind can be categorized into different categories. What are they? Number one, if these winds are very large in size, if they can cover the entire length and breadth of this planet, we call them as what? Planetary winds. Okay. This wind we call them as what? Planetary winds, my friend. We call them as what? Planetary winds. Okay. Planetary winds. A wind which, say for example, you call them as planetary winds. The winds which occupies a larger area but not to the size of the continent, right, or not to the size of the planet, you call them as what? A regional wind. Right, you have planetary wind, you have regional wind, and the wind which flows in a very small area, we call them as what? Local wind, my friend. We call them as what? Local wind. Okay. You call them as a regional wind, you call them as planetary wind, and you call them as what? Local wind. Okay. And my dear friends, if you ask me, okay, give me some of the examples of planetary winds. Totally, there are 6 planetary winds, my friend. But three names. Okay. What are the 6 planetary events and what are the 3 names you have if you ask me, right? My dear friends, you call them as what? Trade wind. Number 2, you call them as what? Westerly. And 3, we call them as what? Polar winds, my friend. You call them as what? Polar winds. Trade, westerly, and polar winds. These are the 3 winds. But just now I said there are 6 planetary winds, right? These winds, right? Pair of winds. Trade, westerly, and polar of northern hemisphere. Trade, westerly, and polar of southern hemisphere. That's what we have seen here. See, we have seen the pressure systems, right? And between the 7 pressure systems, see, polar winds, westerly wind, trade wind of northern hemisphere, again trade, westerly, and polar winds of southern hemisphere. Okay, right. So totally we have 6. Names are only 3, but in both the hemisphere, totally I have 6 winds, my friend. And when I talk about the regional wind, my friend, regional wind, right? A large area wind, which can almost occupy the, say for example, area of a continent, right? At least a subcontinent region, right? You call them as a regional. And there are the prominent regional wind, but one of the most important regional wind of the world. What we'll be studying here, we'll be discussing about this concept called as monsoon, my friend. Monsoon is a regional wind. Okay. And local wind, plenty of local winds we have. Plentiful of local winds we have, my friend. Okay. Plenty. See, for example, even when I talk about Assam, right, you'll be experiencing this wind called as Bardoli Chira, sometimes Kal Baisakhi, tea showers, right, nor'westers, right. All these winds are what? Local winds, right? Local winds of the world also we have, my friend. Plenty of local winds of the world we have. Okay. So we'll be discussing those winds in detail, my friend. Okay. And when I talk about this upper air wind, my friend, this upper air wind is very popularly, either you call them as a geostrophic wind, or very popularly this upper air wind, you call them as what? Right, very popularly you call them as what? Jet streams. Right, you call them as what? Jet streams, my friend. Right, you call them as what? Jet streams. Okay. And my dear friends, all these winds, planetary winds, regional winds like monsoon, local winds, jet stream, all winds are ultimately important. Okay, very important, my friend. And that's the reason I said wind itself is very important, right? Starting itself by a market, it is very important. My dear friends, certainty of the question, any examination you write it, your State Public Service Commission, UPSC, any examination you take it, right? Wind is very important and the certainty of the question in wind is very, very high. Okay, right. Only thing is that we have to see each and every wind in detail, my friend. Okay. See, we are going to spend more time in wind. Local wind alone I will be taking in one class. Monsoon in another class. Right? Jet stream, planetary winds, regulators of the wind, in say for example half a class. Somewhere, right, we need at least 5 hours, 4 to 5 hours to cover only the concept of wind. Okay, wind is very important. Okay, that's the reason I'm telling you 4 to 5 hours only we are going to concentrate on wind, my friend. Okay, now what I'll do, so today, right, I'll just start with planetary winds, and before starting with planetary winds, generally I should know what are the regulators of the wind, my friend. Okay. So somewhere, right, I should be talking about the regulators of the wind, my friend. Okay, what are the regulators? Now, what is a regulator of a wind? I'll tell you. What is a regulator of a wind? Any wind has a character. Wind has a direction. wind has a velocity. Okay. So whichever factor which determines the character of this wind, like direction and velocity, that is what we call them as what? Regulators of wind. Okay. We call them as regulators of wind. Okay. Now here, what are the different factors which regulates the very movement of the wind, if you ask me? Plenty of factors, right? Number one, my friend, right? I'll give you four factors, right? Four factors. What are they, if you ask me? Number one, pressure gradient force. Right, pressure gradient force. Now you may wonder, what is this pressure gradient force? Okay, so somewhere you can write it. Somewhere you can write it. A force that is created. A force that is created a force that is created due to the pressure difference. Due to the pressure difference that exists between two places. That exist between two places. It's called as pressure gradient force. It's called as pressure gradient force. I repeat again, a force that is created due to the pressure difference that exists between two places. It's called as pressure gradient force. Okay. So what is pressure gradient force? We have an idea. Now, my dear friends, a few things, whether you understand this terminology or not, you can always write it. Pressure gradient force. See, this is the mother of all forces, my friend. Why exactly wind moves from one place to another? It itself is because of what? Pressure gradient force. And write it. Pressure gradient force acts perpendicular to isobars. Pressure gradient force acts perpendicular to isobars. It acts perpendicular to isobars. Okay. Now finally, last sentence you can write, my friend. Pressure gradient force, very important. It determines both direction and velocity of wind. Determines both direction and velocity of wind. Very important, my friend. It determines both the direction and velocity of wind. Okay. Okay. So what is pressure gradient force? We have taken it. Somewhere I told you, right, pressure gradient force always acts perpendicular to isobars. Whether you understand the statement or not, leave it. Okay, you just take it. But what is very important here, it determines the direction as well as the velocity of the wind. Okay. And my dear friend, sometimes an examination or not an examination in your NCRT says pressure gradient force will be very steep, pressure gradient force will be very gentle. All these things we can almost leave it. Okay. Whether this pressure gradient force will, say for example, exist as a steep slope or gentle slope, gradient. Gradient itself means what? Slope. Am I right? Does this slope exist in reality? If you ask me, no. If you take the value, if you compute it in a graph, right, you will experience a slope-like structure. That's what you call them as a slope. So don't take it very seriously. Okay. So what is pressure gradient force? Very important, I have defined. A force which is created due to the pressure system that exists between two different places. It determines both direction and velocity. Right? Very good, my friends. Number two, Very important regulator. We have what? Coriolis force. Right? Coriolis force. A very interesting force, my friend. You call them as what? Coriolis force. Number one, what is this Coriolis force, if you ask me? This itself is a force that is created due to the rotation of the earth, my friend. Okay. So any moving unstable mass, it can be water body, it can be a flight, it can be a moving ship, drifting ship, it can be a wind, whatever it is. So any moving unstable mass comes under the effectivity of Coriolis force, gets deflected towards a particular direction, my friend. Say, for example, if you're there in northern hemisphere, my friend, if you're there in northern hemisphere, any moving unstable mass, right? Say, for example, if it is moving in one direction, it gets deflected towards right, 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 and right. Okay. If you're there in southern hemisphere, the deflection is towards left, 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 and left. Okay. That's the reason. Plenty of places you can find it, my friend. Say, for example, yesterday we talked about ocean currents, right? We talked about ocean currents, my friend. Take a very close look, my friend. You're taking a very close look in this ocean currents map. Okay, what happens? If you're there in northern hemisphere, my friend, see, deflection is right, 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 and right. You find a clockwise direction, right? Clockwise direction. Okay. If you're there in southern hemisphere, the deflection is towards left, 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 and left. See here, left, 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 left. Northern hemisphere, right, 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 and right. Am I right? Somewhere, my friend, virtually you can see it. Not only in water, my friend, water. That's the reason I said, right? Any moving unstable mass which comes under the influence of Coriolis force gets deflected towards the right in northern hemisphere and left in southern hemisphere. Why do we have this Coriolis force, if you ask me? Coriolis force itself is resulted due to the spin of the earth, my friend. Right? Spin of the earth. Am I right? Okay. So somewhere you can write a definition of this Coriolis force. Very important force, my friend. You can write it. It's a deflective. Coriolis force is a deflective force. Deflective force. Coriolis force is a deflective force. It is caused due to the rotation of Earth. Caused due to the rotation of Earth. Caused due to the rotation of Earth. Right? It's a deflective force and it is caused due to the rotation of Earth. My dear friend, see, wherever, everywhere, my friend, even say, for example, restroom, your restroom. If you're pouring a bucket of water, even the flush, everything, my friend. If no external force is applied, okay, you'll be finding that water will be circulating in a direction, right? If you're there in northern hemisphere, this water will be circulating in a clockwise direction. If you're there in southern hemisphere, my friend, the water will be circulating in what? Counterclockwise direction. It's completely because of what? Coriolis force. Okay, right. Somewhere I told you it's a deflective force. It's caused due to the rotation of Earth. Further, you can write any moving unstable mass. Any moving unstable mass, right, gets deflected towards right. See, what is the meaning of this unstable mass? Okay, when I say unstable mass, okay, any moving unstable mass, my friend, within bracket you can write it as what? Water and okay, wind. Okay, you can call it as water and wind, my friend. somewhere you can write it. Any moving unstable mass, right? Any moving unstable mass gets deflected towards right, in northern hemisphere and towards left in southern hemisphere. Right? So let me tell you, any moving unstable mass, I told you, wind and, say for example, wind and water, right? It gets deflected towards right in northern hemisphere and gets deflected towards left in southern hemisphere. My dear friends, very important. Somewhere I told you means assuming that, say for example, a wind is moving from one high pressure to low pressure in northern hemisphere, my friend. Okay. Under the effect of pressure gradient force, it is moving from one isobar to another isobar. But under the influence of Coriolis force, there is a deflection towards what, right, and eventually the wind will be flowing in such a direction, my friend. This is how this wind flows. Okay, right. So somewhere we have an idea. Okay. So what is Coriolis force? Right. Everything we have an idea. Now further you can write, my friend, Coriolis force determines only the direction of the wind. Coriolis force determines only the direction of wind. Coriolis force determines only the direction of the wind. Okay, it doesn't have any role to be played in velocity. Okay. Everything is very fine, my friend. See, Coriolis force is very important. That's the reason, again and again, I'm telling you. Coriolis force determines the direction, right? Because it gets deflected. See, for example, when I talk about deflecting towards the right, it is going to result in the change in the direction. That's the reason I said it's going to determine the direction. Okay. So, my dear friends, this statement, what I have just given you, is very, very important, my friend. Okay. Right. Deflection in what direction? It's very important. Northern hemisphere it is right and southern hemisphere it is left. Somewhere you by heart it. Okay. Now, and finally, let me tell you, Coriolis force is not a uniform throughout the world. Right. That also approximately I'll just give you the value, and I'll give you one statement also how to remember the value. Right. So now what latitude versus Coriolis effectivity. Coriolis effectivity. My dear friends, 0 degree, that is equatorial region, Coriolis force is absent, my friend. Right? Coriolis force, somewhere you can write it. Coriolis force is absent at equator. And it is minimum in equatorial region. Coriolis force is absent at equator and minimum in equatorial region. Right? And somewhere, my friend, somewhere around 30 degree, the Coriolis effectivity is 50%. Somewhere around 60 degree latitude, the effectivity is somewhere around 86.6%. And 90 degree, it is somewhere around 100%, my friend. So what you can write it? One thing I told you, equatorial region or at equator, Coriolis force is absent. Coriolis force is absent. Okay, right, my friend. See, somewhere I told you Coriolis force is absent at equator. Now, what you can do? I'll give you a statement. You write this statement, my friend. Very important statement. The effectivity of Coriolis force. The effectivity of Coriolis force increases. Effectivity of Coriolis force increases. With increasing latitude, and velocity of wind, with increasing latitude and velocity of wind. Right. So let me tell you, my friends, again, Coriolis force increases with increasing sign of latitude and increasing velocity of wind. The velocity of wind increases, there also what? Coriolis effectivity increases. Am I right? If latitude increases, there also what? Coriolis effectivity increases. Okay. Right, my friends. So somewhere we have an idea. Okay. So pressure gradient force, Coriolis force I have just given you. Okay. Right. And talking about the other forces, my friend, which affects the direction and velocity of the wind. Now comes the third factor, my friend. Third factor. I call them as what? Frictional drag. Right? I call them as what? Frictional drag. Okay. See, simple. Name itself says what? Friction. Frictional drag. Okay. Now, what is an idea here? See, if at all, if you have high friction, my friend, if you have more friction, velocity of the wind will get reduced. Correct? Very simple. Right. The velocity of the wind will get reduced, my friend. Right. On the other hand, if you have less friction, right, you will have more velocity, my friend. So what is an idea? Somewhere I understand friction and velocity, they are inversely proportionate to each other, my friend. Okay. So somewhere you can write it, right? Frictional drag determines the velocity of wind. Determines the velocity of wind. Okay, frictional drag determines the velocity of wind. That's it. Nothing else, my friend. Okay, frictional drag just determines the velocity of wind. Okay, right. Now, my dear friends, only thing is that somewhere I have to have an idea where what will be the amount of friction. See, friction is very simple, right? Don't even means not even necessary to explain it, my friend. Anybody can understand what is a friction. Okay. Now, my dear friends, somewhere I am just asking you a question. Okay, asking you a question, right? Right. More than 1.5 hours you were silent. Okay. So somewhere, okay, we'll have an interaction, small interaction, my friend. I'm going to compare water versus land, my friend. Globally, I'm just going to compare what? Water versus land. Okay. Oceans versus land. Now you have to tell me where exactly the friction will be more and where exactly the friction will be less, my friend. Between land and water, for a moving wind, okay, moving wind, only if it has a movement, you call them as a wind, right? Moving air mass, you call them as what? Wind. Horizontally moving air mass. Between land and water, you have to tell me where you will be having more friction, or you can say less friction, whatever it is. Velocity of the wind in land and water is not same. You have to tell me where you will be having friction should be higher over water. Is it so, my friend? See, friction is more like an hindrance, my friend. Say, for example, You have something called as wind barrier, right? You'll be having wind barrier. You'll be having tall trees which is constructed, which acts as a wind barrier. Even soil erosion, you will be using these wind barriers, my friend. So what exactly all these wind breakers, wind barriers does is that they reduce the velocity of the wind. How they reduce the velocity of the wind? They reduce the velocity of wind by increasing the friction. Right, my friend? So somewhere I understand water it is completely plain, my friend. Right? If that is the case, you don't have any wind breakers, am I right? You don't have any wind barriers. Frictional drag will be very minimum in water, my friend. Friction will be very minimum in water, right? What you will be having in water will be a low friction, right? That's the reason, my friend. Water you will be having what? The velocity of the wind will be very high. So what you will be having is what? High velocity. Water will have low friction. As the case, what you will be having is what? High velocity. Correct? On the other hand, my friend, when I talk about land, land will be having high friction. Okay. As the case, what you will be having is what? Low velocity of wind. So between land and water, my friend, where you will be having more friction, if you ask me, right? More friction is associated with land. That's the reason. See, you would have heard about cyclones, right? When I talk about cyclones, 4 days, 5 days, the cyclones will be live, right? It will be active in oceanic region. But the cyclone, when it enters the land area, not more than a single day it survives, my friend. Why the cyclone does not survive just even beyond 1 day, if you ask me? It is all about friction. It's all about friction, my friend. Okay, right. So between land and water, friction is very less in water. Correct? That's the reason. The wind velocity generally in water will be very high, my friend. Okay. Now, I'm just giving you one exercise, small exercise in the sense, not exercise. You have to identify it. See here, though we have not talked about these winds in detail, between the 6 pressure belts of the world, 7 pressure belts of the world, you have 6 planetary winds. Polar winds of the northern hemisphere, westerlies of northern hemisphere, trade winds of the northern hemisphere. Okay. Versus trade wind of southern hemisphere, westerlies of southern hemisphere versus polar wind of southern hemisphere, my friend. There are 6 wind what it is flowing, my friend. Okay. Now you have to tell me among the 6 winds what exactly it is flowing. Okay. Which wind will have the highest velocity? I'll give you a clue, my friend. What is the clue if you ask me? That wind which near completely flows in water, that is the wind which is going to have the highest velocity, my friend. I repeat again, my friend. The wind which is going to flow in water, right? Okay. That wind which is going to flow in the water, that is the wind which is going to have what? Highest velocity, my friend. Say, for example, this is your, okay, subpolar low, right? This is your subtropical high. This is your equatorial low. This is your subtropical high, subpolar low. Antarctica region is not given here. Okay. So somewhere you have to take a call, my friend. Okay. Number 1, polar winds, westerlies, trade wind of the northern hemisphere, trade wind of the southern hemisphere, westerly of southern hemisphere, and polar wind is not given. Southern hemisphere polar wind is not given, my friend. You have to tell me, right, among these winds, right, which wind flows, right, majorly over water? Polar wind of northern hemisphere, westerly of northern hemisphere, trade wind of northern hemisphere, trade of southern hemisphere or westerly of southern hemisphere. Don't even consider this polar wind, not given. Okay. Now you have to tell me, my friend, which wind, right, flows near completely over water. Approximately, I've given you the name also, right? Westerlies of southern hemisphere. Right. Westerlies of southern hemisphere, my friend. See why? When talk about westerlies of southern hemisphere, see everywhere it is water, my friend. Everywhere it is water. So, my dear friends, among all the 6 planetary winds we have, right? If you ask me, among the 6 planetary winds, which wind will have the highest velocity, if you ask me, it is westerly wind of southern hemisphere, my friend. I do not know how many of you heard this terminologies, right? So, for example, sometimes you come across these terminologies, right? Right, you call them as what? Roaring 40s, furious 50s, shrieking 60s, or you call them as what? A screaming 60s. My dear friends, all these terminologies appear as though somebody is talking about the age, right? Because at 40 people will be very, right, they'll be roar at 40, they becomes very furious at 50s. But people on reaching 60 years, they start screaming, shrieking, am I right? But my dear friends, if you ask me what are they? They are nothing but what? Latitudes. 40 degrees southern latitude, 50 degrees south latitude, 60 degrees south latitude. My dear friends, this is nothing but what? Westerly belt of southern hemisphere. This is the westerly belt of southern hemisphere, my friend. Right? They ask me what exactly all these terminologies talks about. Okay. This terminology simply talks about the high velocity of this westerly wind of southern hemisphere. Standing at 40 degrees south latitude, you can hear as though the wind is literally roaring, my friend. On reaching this 50-degree latitude, this wind becomes so furious. Right, almost reaching the 60-degree latitude, you will hear the wind as though a child is screaming. Correct? Right. So, my dear friends, somewhere I understand they just talks about the high velocity nature of a wind. Okay? Right. Right, my friends. So, somewhere the frictional drag also I have just told you. Okay? So, between land and water also I have justified. And my dear friends, if you want to justify within the land, okay, within the land, see all this terminology, my friend, they simply, right, they depict the high velocity nature of this wind that I should know. Okay, so that's where somewhere I always say wind blowing or wind which is flowing over water will always have a high velocity. Okay, now comes the question, if you are there in land, my friend, land itself I have different features, right? Say for example I have mountain, I have plateau, right? I have plains. Now I'm just giving it to you. You tell me, right? Among mountains, plains, and plateaus, where you will be having maximum friction and minimum friction. If you answer this question, we'll be completing this class only at 2 hours. Okay. Another 2-3 minutes, we'll be completing it. If you don't answer this question, then also we'll be completing it. That is not an issue. Okay. You have to tell me, my friend. Mountains versus plains versus plateau, where you will be having maximum friction. Very good. Mountain is the one where you have the maximum friction and plain is the one where you have the minimum friction, my friend. As the case, what happens? Velocity of the wind will be very, very low in mountains. When I talk about the wind velocity in plains, it will be very high. My dear friends, that's the reason. Only where you have a coastal plains, cyclone will be entering. If you don't have a coastal plains, cyclone will not ordinarily enter, my friend. West coast of India is near completely free from what? Cyclones. Okay. Right. When I talk about east coast of India is vulnerable to cyclones. Why? Because you have what? More coastal plains. Entire Bangladesh is known for cyclones. Why? Entire Bangladesh is a plain. Correct? Right. So between different segments of land, right, where exactly, right, you have a different amount of, right, this friction, that also we have taken it. Okay. Right, my friends. So some of the very important regulators of wind we have taken it. Pressure gradient force, Coriolis force, and frictional drag. Okay. Right, my friends. So I'll also give you one more regulator. Okay. Gravity, my friend. Okay. Somewhere with a star mark, you can have this gravity. I'll explain gravity at the later stage. Right. Whenever you have a wind which is predominantly instigated by this effect of gravity, such winds we call them as what? Katabatic wind. Right? Katabatic wind. Again, it determines majorly the direction. Forget about this direction or velocity. Gravity also plays a significant role in determining the wind. Right? But very rarely, katabatic wind. Right? Not everywhere, my friend. Katabatic wind is not common in plains. Katabatic wind is common only in a mountainous region and edge of a plateau. Okay. So this gravity, I'll explain you somewhere later. Okay. Right. So the regulators of the wind we have seen, my friend. Okay. So with this today, I'll just conclude the class today, my friends. Okay. Right. The subsequent class, we'll have a discussion. Okay. So thank you and God bless.
Mhm.